Today we're going to talk about rational expressions, which is section 12.2 in your book. A rational expression is a fraction that has both polynomials in the numerator and the denominator. For instance, 5m plus 3 over m minus 6. Both of those are polynomials. They have variables and they have numbers in them. And at first, all we're going to do is we're going to look at this and we're going to go, what can m not be equal to? Well, I look at the bottom and I go, I cannot have 0 on the bottom of a fraction. So what number for m would make the bottom 0? So I quickly find out that m cannot equal 0. The way that I could do it out is I could set the bottom equal to 0 and find out that when I solve for it, if I plug 6 back into the equation, it's going to give me 0. Now, sometimes they get a little bit more complicated than that. So let's say I have x squared minus 5 over x squared minus 5x plus 6. And I go, what can x not be equal to? The very first thing I have to do is I have to factor what I can factor. I cannot factor the top, and I'm really not too concerned about the top when I'm just trying to find out what x cannot equal. So I'm going to look at the bottom here, and I'm going to factor into x minus 3 and x minus 2. And I look at this and I go, okay, what can x not be equal to that would give me a 0 on the bottom? So what I do is I set both of these equal to 0. And I find that if x was equal to 3, I would have a 0 on the bottom because that would make this parentheses 0, and 0 times anything is 0. And x is equal to 2. That would make that 0, which would make the whole bottom 0. So I cannot have x is equal to 3 or x is equal to 2. Those are the two things that x cannot be equal to. All right, now I want you to try one. Actually, I'm going to put a few up here for you to try. So you might want to pause the video, do them, and then come back to the video. So what can b not be equal to? And what can a not be equal to on this one? On the top one, obviously b cannot equal negative 7, because if I had a negative 7 in for b, that whole bottom of the fraction would be equal to b. And remember, when I have 0 or equal to 0, and when the bottom of the fraction is equal to 0, the fraction is undefined. This one, I'm going to have to factor. So I have 5a squared plus 2, which I can't do anything to factor that. But on the bottom, I have a minus 4 and a plus 3. I need to set both of those equal to 0. And when I do, I find out that a equals 4 and a equals negative 3. Both of those values would make this polynomial or rational expression undefined. So a cannot equal 4 and a cannot equal negative 3. All right, we're going to go on to the next section, well, still in section 12.2, but the next bit of information is on simplifying rational expressions. So let's say I have something like this, and we're just working with monomials right here at the beginning. Remember, monomials are a one-term expression. You can look at this. Now, if you want to, you could write it all out in detail. You may or may not need to do that. But remember, this is the same as negative 7 times a times a times a times b times b times b over 21 times a times a times a times a times a times b. Those two equal 1. Those two equal 1. Those two equal 1. And those two equal 1. Then I could reduce this I can divide the top and the bottom both by 7, so that gives me a -1 on the top and a 3 on the bottom. So my final answer would be -b squared on the top and 3a squared on the bottom. Now, there's a good chance that you are not going to do it that way. So you'll probably come straight over here. Remember that when you have base numbers that match up, you subtract the exponents and use the number where the larger exponent is. So first let's look at the 7 and the 21. That reduces to -1 and 3, and I would write it above and below it. Then I have an a cubed and an a to the 5th. So I'm going to go 5 minus 3 is 2. The larger exponent is on the bottom, so I have an a squared on the bottom. And the a on the top goes away. Then I have a b cubed and a b, so 3 minus 1 is 2. So that leaves me with a 2 on the top. And it ends up giving me, no wait a minute, I did that wrong. This is a 3, not a 7. It gives me the same thing that I get when I do it out the long way. So you do it whichever way you feel more comfortable doing it. I'm assuming you're probably going to do it this way. Now I want you to try one. Pause the video and then come back to it to check your answer. All right, you're going to reduce this. Let me change the color here. So this is going to be, you're going to divide both by 4, so that's going to be an 8. This is going to be a 1. This is going to be an x to the 4th. That's going to go away. This one's going to be a y to the 5th. So what you have left is 8x to the 4th over y to the 5th. All right, now we're going to change off of monomials, and we're going to do this with some polynomials. This is going to involve some factoring, so I hope you're up to speed on your factoring. So let's say I have an x squared minus 2x minus 15 over an x squared minus x minus 12. This is going to require me to factor both the top and the bottom. So this is going to be x minus 5 and x plus 3. On the bottom, I'm going to have a x minus 4 and an x plus 3. And you can see that that whole term matches up. You cannot, please understand this, you can't mark out the x squared and the x squared because they are added or subtracted to something. You have to get it to the point that you can mark out the whole thing that's multiplied by something else. This and this goes away. You cannot just mark out the x or mark out the 3. The whole thing has to be marked out. So it's x minus 5 over x minus 4. Again, that's a major mistake that's made on this kind of a problem. You cannot individually mark out these terms. You have to get it to the point that everything or every parenthesis is multiplied by another parenthesis, and then you mark out everything that's in that parenthesis. That has to completely match up to mark it out. All right. Let's do one that's a little bit harder. Well, let me have you try one first. Try this one. Pause the video and then come back to check your answer. All right, when I factor this, I have x minus 7 and x minus 2. I have x minus 7 and x plus 5. So notice what can be marked out is that x minus 7. It completely matches. So my final answer is x minus 2 over x plus 5. And that's what that expression simplifies down to. All right, let's go forward. Now on these, you're also looking for what we call are the excluded values, which you already did at the beginning of the section. So we're going to add that to simplifying it. So I have 3x minus 15 over x squared minus 7x plus 10. Again, what I have to do is I have to factor first. So I factor out the 3 on the top, so x minus 5. On the bottom, it factors into x minus 5 and x minus 2. The big key on this is factoring. Now I look and I go, what can x not equal? Well, x cannot equal 5, because if I have a 5 there, this whole term is 0, which I'm multiplying by 0, so the whole bottom would be 0. And x cannot equal 2. Those are what we call our excluded values. Then if I go to simplify this, I mark out the x minus 5 and the x minus 5, so I have a 3 over x minus 2. So they're actually asking you for both of those. All right, you try one. Now you're looking for the excluded values and you're looking to simplify. All right, so go ahead and work that out, then come back. The top, I'm going to factor out the 4, so I have x plus 4. On the bottom, I'm going to factor this into negative 9 and positive 4. So my excluded values are x cannot equal 9, x cannot equal negative 4. When I go to simplify, that and that mark out, so I have 4 over x minus 9. All right, I'm going to give you your homework. Now, if you struggle at any time during the homework, you can always text me and I can help you on the problem that you're on so that you can go on and complete your homework. So, page 651, 16 through 40 even. And it is due tomorrow at noon.